What's up, guys?
Hey, Justin, how's it going?
It's
Steve?
good, man. Appreciate you guys coming to the Stability Matters, a Groundworks commercial podcast. Um, got Steve Barton, CEO of Alchatek, and Andy Powell, VP of Sales. In here in where are we at? We're in Atlanta.
Atlanta.
Yeah, Atlanta. I appreciate you guys coming.
It was a much easier commute for us than it was for you.
Yeah, from Texas. So today was a pretty busy day, driving around looking at sinkholes and looking at all things that your products help us with, polyurethane, geotechnical polymers, leak seal type products. And, I've been in the industry a long time and I feel like, every new opportunity or every problem that I see, there's a new product or a new solution that continues to come up. And I appreciate the partnership that we have because you help us fix things and solve problems. I've learned a ton from you guys, and it's like when you're in the industry for a long time, you're like, oh man, how much more is there to learn? But every day, it's like, man, there's just so much to learn.
Yeah, there's always more.
Yeah, it's crazy. So, Steve, we've known each other for about a year, I think, close to about a year. How did you get into polyurethane? How did you just wake up one day and you're like, I'm going to manufacture geopolymers?
How much time do we have?
Plenty.
So my story goes back quite a long ways. My father was a concrete repair contractor. And so the first time I ever climbed up a drainage pipe to seal a leak, I was 9 years old.
Inside
the pipe. Yeah.
Dad's like, get in there.
And back in those days, we were trying to use epoxy to stop leaks. And if you know anything about epoxy, it's a 2-component material and they usually have long set times.
Yeah.
It's very, very difficult to do. So I grew up in that environment, working weekends and spring break and summers. Always worked in that industry. And it's kind of a long story. My dad bought a franchise from a company called Sinmast, which is a European company that came to the U.S. and they were teaching people how to do epoxy flooring, epoxy coatings.
Oh, like the garage coatings and
that type of stuff.
That type of thing.
Exactly.
Okay.
Yeah, and most of it was for industrial and commercial applications, but also structural crack repair using epoxy. So that's really what I grew up cutting my teeth doing. What happened was 3M came out with a product called 3M Scotch Seal 5600. It was actually made in Japan. I think it was a Japanese product. That was a single component liquid polyurethane that reacted with water.
Okay.
And so you would take that material, pour a little water in it, mix it up, and it would foam up in a couple of minutes and form this real soft, flexible foam. And is a real interesting story. So the first time they saw this product, they thought, sometimes water's coming through these cracks. We want to stop the water before we inject epoxy. And most people don't know the Flint River actually runs under the Atlanta airport.
Really?
Yeah, there's box culverts that just run all the way through.
I had no idea.
Yeah, and as they were expanding the airport, they were extending the box culvert, and they put a section in, and it was leaking. And so they called our company out, and our plant. Now this was before I was very active. I was back in the 80s. But they called us out to fix the leak. Our crew went out there, and they thought, okay, what we need to do is let's stop the leak with this 3M material, and inject that behind there, and it'll seal up the leak from the back, and then we can inject our epoxy in and do our standard structural repair.
Yeah.
So it was the very first job that they did. They drilled holes, they pumped that liquid resin in there, and it came through the crack, which they were not expecting. And they were freaking out. They were like, oh my gosh, we've contaminated this crack. We're never going to be able to get our epoxy in there. What are we going to do? Just about that time, the superintendent from the general contractor walked up, and he looked, he goes, oh, you got the leaks fixed. You guys getting ready to wrap up? And they were like, yes, we are. Yes, we're finished. We're going to get out of here. So that's the first time that we'd ever used polyurethane for sealing leaks. And then from then on, we kind of, just started doing more and more of that.
Just by chance, you were like, you had a plan and part one fixed it.
Yeah, that's right.
Cool.
Exactly. And so from there, when I got out of high school, I spent the summer just traveling all over the Southeast, injecting polyurethane into The MARTA tunnels. In fact, I graduated on a Friday. On Monday morning, I was in the MARTA tunnels.
Wow.
Standing on top of a 20-foot ladder, holding a 50-pound rotohammer over my head, drilling holes. And every now and then I'd have to stop and hang on to the ladder because the trains would be going by.
Wow.
It was very...
what type of equipment? So that was back, was that 80s or early 90s? Okay.
Yeah.
So what kind of equipment were you injecting that with?
We were using Graco pumps, single component paint pumps. It was
Okay.
a Graco 333, which they don't make anymore, but that was the old.
And what kind of
style.
attachment? Were you like DI rods?
Same things we're doing
Okay.
today. We would drill a hole, we would put in a mechanical injection port, tighten that down, put a Zerk fitting on the end, and then you'd have the pump. The hose would come to the gun. At the end of the gun was a pipe nipple and a coupler, and put the coupler on, open the valve, and that would allow the material to flow into the crack.
Okay, cool.
So it's very similar to what we're doing today. Really, that technology has not changed that much, other than the resins have improved dramatically.
Okay. And so 3M still has a product like that? Or
No, 3M exited the market.
okay,
Yeah,
got it.
3M's business model is innovation. So what they do is they innovate, they come out with a product at high prices, they run them as long as those patents will go, and as soon as competitors come in, prices start to drop, 3M exits.
Got it.
So that's their business model, is they're constantly trying to innovate new
come
products.
up with new stuff. Yeah.
Exactly. Yeah, so that's kind of how I got started. So my dad brought this Sinmast franchise. He bought 4 states. I think he bought Florida, Georgia, North Carolina, and Alabama, I think, or maybe it was Tennessee. But he bought a franchise for 4 states, exclusive franchise. And then he found out that they sold the exclusive franchise to several people. And the whole Sinmast thing turned out to be a scam, and it was a big deal. They were pouring tons of money into the marketing. I remember my dad and my brother went down to one of the Apollo Soyuz space launches.
Yeah.
It was sponsored by Sinmast, and they had a race car that they had sponsored. The whole thing was a scam. They were just trying to sell as many franchises as they could. They took the franchise fees, and they declared bankruptcy and left.
Wow.
And so it left a lot of guys, my dad and several other real prominent guys in the industry, just kind of in a lurch. They had good technology. They saw the market potential, but they didn't have any products to inject because Sinmast had pulled out. So my dad ended up hiring a chemist, an epoxy chemist, and started manufacturing epoxy.
Okay.
So that's also what
epoxy for leak seal.
For lots of different things.
Got it.
Yeah, for structural repair. We didn't use it for leak seal at that time because we'd already switched to the polyurethane.
Switched to poly, yeah.
Yeah, and so where was I?
They
Epoxy.
started making your own
Yeah,
epoxy.
so we started making our own products. So when I would, again, summers and at different times when I was out of school, I would actually manufacture the epoxy. So I got a lot of experience doing that. And then when I graduated from college, I went to work for him. And at that time, the company was really small, and we decided.
How many employees did you have around then?
There was 2.
Like
There
you
was
and
a-
him?
There was there was a chemist, and then
Got
there
it.
was a production guy.
Okay.
And then I came on. I was the next guy. Now he still had the concrete repair contracting business, which was the bigger business. This business just kind of fed that business. And so over time, I was learning the business. We made epoxies for joint sealants in warehouse floors, epoxy coatings, epoxy gels for patching concrete, epoxy mortars, different things like that. But we were still doing a lot of injection. And in fact, we were 3M's largest customer. 3M came to us and said, we want to just sell through one master distributor. So we want you, instead of selling you direct, we want you to buy from this master distributor. They were one of our competitors. So we were like, no, we're not going to do that. And just to get into the long version of the story, when I graduated college, my parents gave me as a graduation present a trip to Europe, like a 6-week backpacking, low budget.
Sweet.
Eurail, here's your plane ticket, your Eurail pass, $500.
Figure it out.
Go figure it out. And a buddy of mine, his parents gave him the same thing, so we went together. Interestingly enough, this buddy introduced Andy and I when we were in high school.
Sweet.
Yep. But he graduated 6 months after I did, so I worked for 6 months, and then we went on this trip to Europe. And while I was over there, my dad could not stand that I wasn't working. It drove him crazy. So I called home one day, and he said, "Hey, I got a meeting for you with this guy in the UK. He makes polyurethane. I want you to go see him. It's like, okay. So I went, I had this meeting. He showed me this big range of products, and we knew one product. We just knew
Right.
the 3M product. He had different rigid foams, semi-rigid foams, flexible gels, just a whole range of products. And I was just blown away by it. I'd been doing the work, and I loved that kind of work. Like I loved the foam. I just loved the fact you just pour water in this stuff and it turns into a solid foam in,
Yeah, and
in a couple of
expands
minutes.
and yeah.
Yeah, it's really, really neat. So while I was standing there talking to him, he said, "You guys should make this in the States." And I was thinking, I was 22 years old. I was thinking, this stuff is magic.
Yeah.
We can't make that. We make epoxy. It's easy. You just mix a couple chemicals together. And so fast forward, I go back home. 3M gives us the story. We want you to buy through this distributor. We said, no way. And I reminded my dad, I said, hey, remember this guy in the UK said, maybe we should make this in the States. Why don't we reach out to him? So my dad reached out to him. They cut a deal. He flew over and taught me how to make manufacture polyurethanes. So that's kind of how I got into it. Right?
Got it.
So it was a structural thing, and then leak seal. We were making epoxies, and then I learned how to make polyurethanes, and then we just kind of moved forward from there.
So, for people that, a lot of the story's great, and there's a lot of questions that I have for that. One, for the younger generation, for guys and gals that are maybe not 9 crawling in tunnels and leak sealing things, because I don't think that's a thing. I don't think we can do that today. But
right.
for people that may be thinking about careers or their trajectory or their pathway, from a leadership standpoint, and somebody that's had boots on the ground and done the work, what do you think some key things, if you were to say, man, I wish I could get this point across to a younger generation, or if you just do this, or if you're open to this, what are some wise words from your experience?
Okay, so words of wisdom for the younger generation.
Yeah.
Number one, there's no job that's beneath you. Do it, right? Just do whatever the work is. Do the work. Work hard, especially when you're young. It seems like a lot of the kids these days today, they see what's going on online. They look at the Facebook and Instagram and TikTok, and they think, oh, my life should be like that.
Right.
No, that's not reality. That's not real life. Real life is working hard, and you got to earn it when you're young. It pays off when you get older. So that's why I would say number one is do the work. Don't be afraid to do hard work.
Yeah.
There's a phrase: successful people are willing to do what unsuccessful people are not willing to do.
I totally agree.
And that's, it's true of anything in your life. If you want to lose weight, somebody that's successful, they're going to do the hard work. They're going to say no to dessert. They're going to get up early. They're going to work out. They're going to do all those things. Unsuccessful people aren't willing to do that. If you want to be successful in this life, do the work. Yep.
No, I like that. In my own career and in my trajectory, a lot of times people ask me, oh, I just graduated college and I got this degree and, I deserve this job, or I earned the right for that job. You didn't earn the right for none of that.
That's right.
You may have completed your education. Congratulations, that's difficult, but you got to earn everything. You got to earn your job. You got to earn your place, your take. And some of those things, to speak about the successful people are willing to do the things that others aren't, is you have to lay the foundation for things. And so just thinking about your trajectory, right? You're the CEO of a chemical company that's pretty successful, and the foundation was laid when you were 9 years old, sealing pipes.
Yep, that's right.
And you got all of that. Had you not been on that pathway, and had you not gone through that and been open to doing all of those things, your ears wouldn't have been ready in the UK to, to remember that experience. So, you don't know what you don't know. And if you don't show up for the things that are difficult, you may miss big opportunities. Andy, what do you think about that?
I would say for the younger generation, that don't be afraid to learn a trade. Don't be afraid to say, I'm not going to go to college. I'm going to learn how to weld. I'm going to learn how to be an electrician. I'm going to be a plumber. You'll be making so much more money than these people coming out of college. I mean, those guys get paid a lot, guys and gals, you know. If I met a welder one time when I was at a hotel, he was 24. He had taken all these classes. Now he's underwater certified welding on oil rigs, making like $250K a year.
Oh, working 3 months.
And not having to work that much during the year, so he can have other jobs and do welding on the side. So he was just killing, and this guy's 24 years old, and I was just like, man,
I met a woman.
I should have done that.
I met a woman at one of the conferences that we attended, and I was like, "What do you do?" And she's like, "Underwater welding, and then I weld in Alaska." I was like, "What do you do?" She's like, "I weld aluminum, and which is super difficult, right?" So I was like, "I'm just curious, what do you make?" She's like, "Well, I made about 550 last year, like 550 G's welding aluminum, you know, and taking half the year off." It's awesome.
My dad was a mechanical contractor, and the pipe fitters always made more money than anybody because they were welding all the steam pipes and things like that, and they were always way higher paid than anybody else. All the plumbers, all the electricians, the HVAC guys, they got paid well, but the welding guys, the pipe fitters, they had the money because their stuff had to be perfect.
So you've been tell me about y'all's story. So you've been with Steve for how long?
I've been with the company since it started. So, you know, Steve went after school. We were college roommates. After school, he went into their family business. They were making epoxies, polyurethanes. He did sales. He did some entrepreneurial things on the side. He was never satisfied in one spot for too long. So I followed what he was doing, and then I got into the pipe and precast industry. So I was working for a family business as well. My father was importing pipe machinery for making concrete pipe and precast. So we would come in when there's a new pipe plant being built, and we specialized mostly in the big reinforcement welding machines, these big automated cage machines that were made in Germany. So they'd send these in, and I'd spend 2 or 3 weeks at a plant and install this equipment and then train people how to use it. And it's some pretty cool stuff, you know, welding giant cages, some of these cages that go in like a class C or a class D 12-foot diameter concrete pipe that's got like a 13-inch thick wall.
Yeah.
The cages weigh almost 2,000 pounds, and there's 2 of them inside a pipe like that. So that's massive machines that we were putting in. So did that for quite a while, and then that morphed into us sourcing out different types of molds and things that led me to go to Turkey and China quite a bit, where we were dealing with foundries and machine shops, bringing in molds that were used as part of the pipe manufacturing process. Then the housing market collapsed. We had the financial collapse.
The 07, 08?
For us, it started really around 2007, and then it devastated the pipe and precast industry because, you know, the housing market collapsed. The first thing you do when you're going to build a new neighborhood is you clear the land and you put all the underground infrastructure in, all the stormwater pipes. So suddenly these neighborhoods that are partially under construction just stop, and all the pipes already in the ground. No new developments. Nobody needs pipe. Next thing you know, we're dismantling pipe plants that we had built a year earlier, and our industry contracted by about 90%.
Wow.
I mean, it was massive, and it didn't come back for years. And so knowing what Steve, was always doing, and with his connections in, epoxy and polyurethanes, it was actually Steve's suggestion. He said, listen, he's like, this business, concrete repair, is a business that weathers the storm, whether you got a good economy or a bad economy. If it's a good economy, there's all kind of new stuff and still the old stuff that we can work on. If it's a bad economy, people are preserving their infrastructure.
Preserving what they've got.
And we consider infrastructure anything, something that's built, a building, a tunnel, a pipe, all that's infrastructure, roads, bridges. So he said, you've got connections that can help you get in with utility contractors, the people that are actually installing concrete pipe, the people that maintain pipe, the people that are putting lift stations in, essential type, services for sewer, wastewater plants, treatment plants. And so I was like, you're right. So I talked to my concrete pipe customers, and they hooked me up with their customers, which are like utility contractors, people laying pipe. And what we found out was that, yeah, they run into a lot of problems that polyurethanes and epoxies are solutions for. So they put in, say, for example, a new lift station, and they damage it when it's going in. They got these huge track hose, and they crack one of the risers. And, well, it's got to be epoxied back. So
yeah, you can't pull it out and start over.
So I would get these calls. All right, we broke a big giant lift station section. Come on in and fix it. And so my pipe people would feed me these leads, because these contractors would break stuff, or they would install things wrong, and then they would call the manufacturer and say, your stuff is bad. It's a bad pipe, and they'd blame them. So the blame game, I didn't care. I just got called in every time. And so a guy from where Steve was working actually taught me how to do crack injection, and we were using products from his company. And I found out that really with almost 2 polyurethanes, you can stop just about any kind of a leak with just 2 products. And I know there's lots and lots of products, like we have a lot of them. But man,
so many products out there.
I learned that you get a good expansive hydrophobic, a good hydrophilic, get some oakum and a pump and whatever you need, and you can just stop any kind of leak. So I did that for about 5 or 6 years, and then Steve was making a change, and he said, I'm going to start, this is about August of 2012. Steve said, I'm going to start a new company, and I'm going to call it Alchemy Polymers. Would you like to come on board and help me? You can be my sales guy, my electrician, my plumber, I'm a pipe fitter.
That's awesome.
And it started like that. And I'll tell you what, it's been a life-changing experience. It's been the best 13 years of my life. Every week, something new. You know what it's like. Every week is some new challenge. We're doing work for NASA. We're doing work for Disney. We're doing work, for somebody's house. You just never know. Every week is something cool, something different to do.
Really different.
And I've just worked my way up as the company has grown. And I had to learn how to do everything out in the field. We had 4 people. Then we lost our tech guy because we just didn't have very much field stuff going on as a 1-year company. So suddenly it was like, hey, we just sold our first rig, and our guy quit. So you're going to go start up the rig on a Florida DOT job.
Nice.
I don't know how to run a rig. Oh, you'll figure it out. You've installed equipment.
You should have seen Andy's face when I told him. I was like, Andy, you got to go. I can't do it. I don't know anything about that. It's like, yeah, you do. You're very mechanical. You're going to figure it out.
Everything's going to work.
Yeah. And so what happened on that job?
Yeah. So first night, 3:00 in the morning, in the middle of Arcadia, Florida, you can see out in the swamps, the alligator eyeballs looking at you, and strange people riding by on bicycles at 3:00 in the morning, and we're out there with a crossed over hose. The very first thing we did was cross over the hose, and that's when I learned you always should put a recirc system on your rig. We didn't have a recirc system, so I have 2,000 PSI on my hoses and no way to bleed the pressure off of it. So I'm putting on like 10 layers of garbage bags and 5 safety glasses and slowly cracking these fittings to bleed the pressure off. Meanwhile, the DOT people have gone home. They're like, these people don't have any idea what they're doing. So the next night, the generator wouldn't run. It wouldn't start on a brand new rig. And so the DOT people went back home. And then we worked all day replacing the generator. Got there that night, got it going, got it pumping. Took 3 nights to get it rolling, and we finally overcame all I couldn't come back home without, I have a reputation now. I got to get all that poly in the ground. I can't come back with full drums. That's not acceptable. So we got it going, and I learned the hard way, but
that's the best way to learn.
It is the best way to learn. One of the things, finding a way.
Yeah.
I mean, you learn so much when you're up against the wall with challenges, and just the people that find a way are the ones that persevere and
that's right.
Succeed, and you end up learning a lot. You probably learned, like, what did you learn? What are the 3 key lessons you learned from that early on in your career?
One, I should have reached out to other experts in the industry and learned. I should have asked more questions. Should have kind of paid attention to what was going on around me. Like at that time, I was like, oh, this guy takes care of the equipment and the rigs and the training. And I should have been, I thought it was cool, but I should have been digging in and learning that a lot better than I did. So never pass up a chance to learn and ask lots of questions. The second,
Just real quick
Mhm.
on that. For young people or even older people, I see it a lot where people have too much pride sometimes to learn, and it's always blown me away when I hear somebody, they're like, no, 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 I don't need to learn that, or they're not open and willing to hear that. Um, but as like me, my personal philosophy is that I'm the sum of all of the choices that I've made
Mhm.
at any given moment in my life. Like tomorrow, I'm going to be the sum of everything up until that moment.
Right.
And when somebody offers you their perspective or offers you an opportunity to learn something or education, it's like, why wouldn't you? What What's the worst thing that could happen? You learn something that
Mhm.
changes your perspective. And anyways, so it's just interesting to me how people miss those opportunities
You're
sometimes.
1,000% right. My whole life, I have always stopped people in the middle of conversations, and if they said a word I didn't understand, even if I felt like I was going to look like an idiot, like I should know that word, I'll stop them and say, "What was that? Can you?" And people are always happy to explain it to you, and then you come away with so much more knowledge rather than, "Oh, well, I want to look cool, right? So I'm not going to ask what that is," and
We all
then you don't
speak
learn
different
anything.
languages. I mean, all of us, even though we all speaking English, right? But our backgrounds and our culture and like where we're from and like our street slang or whatever, we all have like different languages, and so it's important to clarify that kind of stuff.
I was watching one of our young guys. I won't name his name because he'll know who it is. He'll know who it is
He already
anyway.
knows who it is.
I probably
But
know who it is.
we were at DFI in Madison, Wisconsin, and this engineer was talking about some grout injection techniques, and I knew my guy didn't know what he was talking about. But I was watching him because I wanted to see what he asked him. What is a machette tube? What are you talking about? What is it? How does that work? But he could not wait to say what he knew. I could see it. He was just, will you please finish so I can say what I want to say? And then I had a coaching moment with him later. I was like, you got a really good opportunity right there to ask questions. I said, the more you ask questions, it's actually even in sales. If you just keep asking people questions instead of trying to sell them, the sale will come to you.
Well,
It's
and
just
like
natural.
focusing on the problem that people have versus the product that people
Exactly.
versus the product or whatnot.
So ask
So what
lots
was
of questions.
what was number two? So
Well,
you said there were a
probably
couple
always
of
put
them.
a recirc line on your 2-component rig.
So for
Um,
people that may not know what recirc is, like
So
what do you mean?
yeah, so on a polyurethane, a 2-component rig, it's all self-contained. Either in a box truck, a trailer, generally, and
And it's
there's
so since we're on it, let's just break it down.
yeah.
You got an A side and a B side of chemical in barrels or
Mhm.
totes.
Yeah, so for those that don't know, if you look it up in the dictionary, like what is the definition of polyurethane? The simple version is it's going to be a blend of isocyanate and polyol, and your isocyanate is your part A of a 2-component system, and then your polyols, and then there's other chemicals in there too, like surfactants and catalyst packages and
Blowing
things that's on
agents
your
and
B side, and a blowing agent. And so a plural component proportioner or a reactor, or 2-component pumps, they take the A and the B and they heat those materials up to a temperature at which the viscosities will equalize. And so when we make products in our plant, we test them in the lab for viscosity, and we figure out at what temperature does the A side reach 200 centipoise, because we know at 200 centipoise, fluids flow really nicely. So we use
so that becomes like your manufacturer specs. You say at X temperature,
exactly
proportion or
So
Right,
A
right.
side, we do a viscosity curve on the A, and we find, okay, 100 degrees is a really good spot to get 200 centipoise. And then we'll take our B blend, and then we'll do a viscosity curve on that. And depending on what product it is, maybe it's 110, maybe it's 115
Right.
for the B side. And so these pumps can take that A and the B and heat them up in one pass over heaters, pressure them up, and send them out through a heated hose bundle where there's the A and the B heated hose, and that A and B are going to come together in an impingement gun. So in that hose bundle, you will build up potentially, 1,500 psi of pressure where those A and B are coming together in the gun.
And they meet at the gun. And there's multiple different guns that are out there.
Different guns out there. But when you're doing like injections in the soil and you're going through a pipe, if you not know what you're doing, which I didn't when I went down on that job, you can potentially cross over your hose. Like if your pipe is plugged up in the bottom and you open the valve and you pull the trigger on that gun, and the mix can't go down the pipe, so one side will try to overpower the other. Had that happen, so my A went up the B line on my whip hose, and of course it reacts in the hose. So now I've got that.
You got the
1,500
foam
psi
expanding inside the hose.
So now all that pressure is trapped in my hose bundle. So if I have a recirc kit, I could go back to my reactor or my proportioner, flip a couple valves, and it would send the material back to the drums through a couple braided high pressure lines. So it's just it's standard on it. I don't know why those people we worked with to build our first rig did not tell us, it's like I was still like should go back and talk to them about that. They really set me up for
it's a simple, inexpensive
recirc pump.
Yeah, a couple $100 for some valves and a little bit of braided line at the time. So yeah, that was the second thing. And then the third thing I learned was, and I would teach people this because I eventually became our field trainer. And so as we would sell rigs, I would train contractors. I trained a lot of people at JES in Mount Valley, Indiana Foundation, the first original 3 branches before there was even a Groundworks. I was training y'all's guys how to use our mixed master gun, how to lift concrete, how to run their rigs. And the thing that I always teach anybody I train is no matter what's happening on the job site, act like everything's cool. Because a lot of times, especially on a residential job, someone's watching you. And when they see you get flustered, or maybe you just shot foam all over the guy's fence, act like everything's cool.
It's got to be all good.
And they'll pick up on your vibes. If you start panicking or getting upset, the customers are going to pick up on that, and then they're going to start looking for things that aren't going right. And next thing you know, it's like, well, that's not completely level, or, oh, there's some stain now on my concrete. I remember we were in a house in Pompano, and the guy unleashed the gun somehow, and he shot foam, and it went right across the guy's wall, across a painting of Jesus on the wall, and then up onto the ceiling. And he was about freaking. I was like, everything's cool. Just act like it's cool.
Everything's gonna be fine.
And the customer walked in, and saw it, and we were just like, stuff like this can happen. Everything's cool. He was like, wow, man, that's pretty cool. Well, I was gonna repaint that anyway, and nothing happened. I'm not saying that it always goes down like that.
Yeah.
But we've been freaking out.
But the energy that you put into things, right?
Mm-hmm.
Like if you're putting negative energy into it, then it's just gonna exponentially freak people out.
So lesson 3. For everybody out there, no matter what's going wrong, act like everything's fine. The next thing you know, it might be, getting it turned around. If you start getting flustered, it's just going to make it worse.
Yep, for sure.
So,
all right. So you guys just kind of built the plane while it was in the air then in the beginning a little bit.
We just pushed it off a cliff, built it on the way down. Those were some wild times.
That's awesome. So, you just say, okay, cool. Like now I'm going to start alchemy. So tell me a little bit about that. Like, what did that look like? Where were you at? Were you in your 20s or 30s at that point?
I was late 30s at that time.
Late 30s.
Yeah.
Okay.
So maybe in my 40s.
40s.
Yeah, I was in my 40s.
So you just sat down, pen and paper, and you said, I think this is a good idea, or...
I thought it was a good idea. Really, it boils down to I needed a job, and I'm unemployable. Nobody will hire me, so I had to start my own company.
Because you have all the experience that you have, and it's like,
yeah, because it's what I was made to do. I owned a home building business for 10 years, and I loved that industry, but it wasn't what I was built to do. This is exactly what I was built to do. I have a very unique background, both heavy on the contracting. From growing up in a concrete repair company family, having the home building business, I learned a ton about construction doing that, and then I also have the manufacturing experience.
Yeah.
So it's very, very unique, and like I said, this is just what I was made to do. I had some good contacts. Started out, our very first sale was to China.
Really?
And in the early years of the business, I spent a lot of time in China, about 6 months total, over about a three-year period. We were lifting the high-speed rails
Really?
and some of the older tracks also. It was very, very good experience. And I was doing a lot of international. I did work in Malaysia. I did work in Australia.
So are
worked on
the rigs similar, over there, proportioners like real similar
We
to
sold
what
it all
we
to
do?
them.
Okay,
Yeah.
cool.
Yeah, so we sold them the PMC equipment. They put it on a little train, I guess you'd call it, pushed it into the track. The first project we did was a lot of fun. We had 3 hours of track time a night. This was the busiest track in China. It's right outside of Beijing, near the Bottling.
Bottling.
Yeah, Bottling is one of the primary places where all the U.S. presidents go and get their picture taken at the wall, the Great Wall of China.
Yeah.
So it was right there. And they gave us 4 nights. They gave us 3 hours a night. And in 3 hours, we had to pull all the equipment onto the track. And everything was disconnected. So we brought the pump, the hoses, they were all tied up together. The generator, the air compressor, everything was separate. And we started out, me and another guy were standing there, and there were 150 Chinese engineers all standing around waiting on us to do our thing. And we got all ready to go. They had pre-drilled the holes. And this particular job was a 3-foot thick slab sitting on top of a 2-foot thick sleeper slab. So we were going through 5 feet of concrete.
Wow.
So we drilled about a 1.5 inch hole. We built special packers that would go down, because I was concerned that if we just, normally in slab lifting, you're drilling a hole, you're just injecting right through it.
Yeah.
Right. Well, in this case, you had 2 different layers of concrete sitting on top of each other. And my concern was if we started injecting and it went down and started to set up,
Then
that
you
it would
separate the
it would get in
sleeper slab.
between, and we'd end up lifting the one slab off the other and not really fixing the soil.
Mm.
So we built these 4-foot long packers to get below that first section of concrete.
Kind of like a turkey baster.
Yeah. Yeah. Okay.
I mean,
Little higher
it's
pressure.
like close to Thanksgiving,
like
man.
that.
I'm just
Yeah,
thinking
yeah.
about turkey,
That's
turkey
right.
basting.
Yeah. So they did the pre-drilling, and we got on the first hole, and we brought 4 guns with us, and we brought this prototype gun. And the guns that we used, they were fusion guns, I think, at the time, which is not what you want to use. It's got an air motor on it.
Mm.
And we pulled the trigger on that, and it was a dead hole. They hadn't drilled all the way through.
They didn't drill through it all the way.
Pulled the trigger, foam blew up through the whole gun, up into the air motor, just locked it up. And we've got, like I said,
Qigong done.
all these guys standing around us, and I was just going,
No pressure.
if we don't do this right, I think they're going to eat us. that's how I felt at the time.
So did you take his advice and you're just like, everything's cool? You're like, oh yeah, man, it's all good.
Oh yeah,
This happens.
absolutely. I looked at the other guy, and I was like, go get another gun and just act like this is what was supposed to happen.
You just go dead hole.
Yeah. So that gun, we sold it to our distributor. The distributor sold it to the railroad. There was import duties, freight.
Mm-hmm.
That gun was probably $5,000, and it lasted 1 pull. So we kept going. We finally got the next hole. Then we started testing all the holes,
Right.
making sure that they were clear. And then it started going okay the first night, and the second night it got a little better. The third night it got a little better, but we were burning through these guns because we kept having problems with the foam going up into the air motor of the gun.
Okay.
And so we would try and rebuild them. We got down to where the only thing that was left was this prototype gun, which eventually turned into the Mixmaster.
Okay.
We didn't have any way of flushing it because it was just a prototype. And the first 2 nights we burned through those 4 guns. The next 2 nights we only used the Mixmaster. Now imagine injecting, pretty fast polyurethane foam, and when you shut the valve, you have no way of flushing anything out.
Yeah.
So we just had to keep foam moving through that. No matter, if we pulled off
You're
the
like,
hole, we were shooting into a
Into
bag.
a bucket. Yeah.
But at the end of the 4th night, they wanted us either to use all the material, because this was just a test, or do the entire section of track, which was probably 1,200 feet of track. The 4th night, we got finished. We had a little bit of material left. We went back and burned through all the material, and was super, super successful.
That's awesome.
So you asked earlier, so what are the lessons for the younger generation? One of my big lessons is never, ever quit. you don't lose until you quit. When you quit, you're a loser.
Yeah.
Right. If you don't quit, you take your hit, you get up, dust yourself off, and you move forward. And you got to know in life, you're going to get hit. Everything's going to go smoothly, and then something's going to catch you off guard, right? From out of nowhere, something's going to knock you down. And as you get older, you just realize, okay, I didn't expect that thing to happen, but I knew something was going to happen. And you just got to get up.
Because it always does.
It always does.
And you don't even know where it's coming from.
That's right. So just get up and keep moving forward and keep moving forward. And,
that's why it's always funny, Steve, like when one of our young guys comes in, he's like, man, I had really bad news for you. I'm thinking someone's died, we'd lost our biggest customer. Well, what, like, that's bad news. And the guy's like, my laptop won't work. I can't get it to. I'm like, God, don't do that to me. You're not old enough to know what bad news is.
Dude, get
yet.
a piece of paper, pencil and paper. Who cares? Deal with it. Figure it out.
Yeah. It's like, you haven't been around long enough to know.
Yeah, that's not bad news.
To take those hits.
Mm-hmm.
So everybody goes through them eventually, and don't quit, right? So.
Yeah. I mean, that's really good. I mean, especially if you're in this industry, like I've been in this industry my whole life. You have as well, and you've been in adjacent industries and this one. What do you like? What are some of your favorite projects that you worked on?
Quite a few. I think one of the coolest ones that we got to do was this is why we do engineer outreach so much, because when something goes wrong, somebody's going to call an engineer, and if those engineers know that we have solutions to problems that they could come across, then they're going to give us a chance. And so in Florida, there was a project where they were doing a big excavation for an expansion on a water treatment plant. And one of these giant buildings that they were going to build for the water plant, a big giant tank, I think it was a big clear well of some kind, is partially embedded in the ground. So about 25 feet of this building would be in the ground, and then it's on piles because it's full of water. I think it weighs a lot, so it is on piles. So they had a steel sheet pile around the whole excavation. It was probably, 150 feet across in both directions, and excavated down 25 feet. They had dewatering going on everywhere because obviously we were in the water table, so they're keeping that water pumped out. And they come in and they put the first test pile in there, and they drill down with it, put the first test pile in, and they fracture the rock where they hit the limestone. And this is about 30 feet below the bottom of the excavation. So now we're about 50 feet below ground level. And they fractured the rock on a Friday afternoon, put this test pile in, left for the day, and they come back on Monday, and the thing is a swimming pool. The whole thing was full of water.
Because when you fracture the rock, all that water table,
aquifer, Florida aquifer, full of, Swiss cheese, limestone down there full of water. It came all up in there, went up through all that 30 feet of soil and filled up that thing. And some of the big geotech contractors were on site. I won't name any names because we do business with them, but they were both like, sorry about your luck. I do not know how to fix this. So we got contacted through engineer, and they said, can you come look at this? And the construction company was one of the big ones in the whole country, like probably top 10 construction company in the whole world, or the whole United States. They didn't want me to, they didn't want us publicizing what was going on.
Of course not.
Their whole job came to a halt, and everybody's looking for a miracle. So we went down to their local contractor that uses our poly that we trust, took a look at it, and we said, yeah, this is a tough one, but I think I have an idea. What if we were to send a drill pipe down right next to where the test pile is and where all that water's gushing out? And they estimated it to be about 300 to 500 gallons a minute was the leak.
Wow.
So and you can imagine that all weekend going, what they found when they came back. So I said, normally we would try to get on the positive side, try to get under that rock and try to get some poly down there and let it set up and react. And fix it from the positive, but there's no way to get to it. So
yeah, you drill through the rock and then you end up springing another leak.
Springing another one. So we said, my best idea is let's put a 2-inch drill pipe down right next to the test pile. We will put as much AP 700 down this pipe as we can with the fast catalyst using diaphragm pumps. And a 2-inch diaphragm pump can empty a 250-gallon tote, in about 5 minutes or
so
less.
Like what kind of pressure is that at?
Just running 100 psi, but they're high flow. So they had to fill the one end of this area with gravel. They brought all these pumps in to suck that water down.
So sucking the water down.
Suck the water down. We put a mini excavator, a crane was there, lower the mini X in there, drilled the drill pipe. They put what looked like a wellhead on top of it, and then we lowered in 2 totes and 2-inch diaphragm pumps. Got everything hooked up, and we were it's time to hit the go button, and the air compressor quit. Of course, and no backup air compressor.
No.
And I remember
he got probably like
$100,000
worth of staging already at that point.
We have we have about $25,000 worth of chemical catalyzed up at that time, ready to go, and the air compressor quit with product starting to go down the pipe. So now it's wanting to react.
And come back up the pipe.
Somehow God favored us. The compressor got going again.
Wow.
We dumped those totes down there, and the idea was to set off a giant polyurethane bomb right there. Use that 30 feet of overburden to keep our material trapped down there. And hopefully it would be a big enough poly explosion to just push through that hole and shut the leak down. And the only thing we saw happen was out in the middle of this big excavation, there was a giant geyser, and it was off-gassing. There's this big, looked like Old Faithful, big geyser went off, and then everything was still, and then there was nothing. And then they're like, okay, we got one more tote. We got to make the call right now, or this pipe is going to be locked up. And the guy's like, all right, let's just see what happened, because it's like a $25,000 decision to put that other tote down there, because we made no guarantee. And it worked. It actually sealed it off. And then 2 weeks later, the same thing happened on that site, and they did it again, same contractor. And actually, we did another one like 2 weeks ago and shut off another one of those the same way, basically using overburden, super fast reacting, the 700 with the Cat 107. It's a super fast Cat. I mean, it'll go off in like 1 or 2 seconds. I mean, it's just boom. And it worked. That was a really cool one, because it was cool to see like this huge project grind to a halt. We're going to have to redesign the whole thing. It's going to cost millions. And instead,
what would have been like, I mean, just for comparison, what would have been a traditional solution in something like that? Like, is there a traditional solution?
I mean, I'll name one name, Keller was out there. That's the largest geotech contractor in the world. They didn't know what to do. They're like, we don't know what to do on this one.
Yeah, there is no traditional for that. It's pump whatever you can down there, and cement's just going to wash out. Really, polyurethane was the right solution. Sometimes sometimes on a big project like that, you've got to pump a lot of material really fast, and it's a big risk. Like Andy said, installing that stuff to the contractor was $25,000 a tote.
Yeah.
But sometimes you just got to punch it in the mouth.
That's what we did.
And that's the reason for the diaphragm pumps. I don't know if you know what a double diaphragm pump is, but it's a big pump. It's air operated. It's a 1-to-1. So if you put 100 psi of air pressure in, you get 100 psi of fluid pressure coming out of it. But you can get those pumps any size, and like Andy said, they'll empty a tote in 5 minutes.
That's awesome.
Yeah, shutting down big leaks are fun. I love lifting concrete and stabilizing soil, but there's something about stopping water from getting where it's not wanted, whether it's through the ground or into an elevator pit or a tunnel. And the more leak, the better. I like shutting them down.
So one of the things, like in our industry, polyurethanes have been around for a while, but in terms of, the engineering community, the forensic community, geotechs, contractors, there's not a lot of people that really, the industry knows a lot about what some of the 2 components can do, and maybe a little bit of single component. But what are the things that are in our way as an industry? What would you say? Like
ignorance. People just not, like I said, I've known about this stuff my whole life. And so it's strange for me to go talk to an engineer who's not familiar with it. Now people are becoming more and more familiar. But I've said for decades, if the pie is this big and us and our competitors are slicing the pie up, we're only slicing up about 10% of it, right? The rest of it is lost to ignorance. People don't understand that this technology is available, that it's fast, that it's powerful, that the techniques can be very painless. So I would say that's the biggest obstacle.
I agree. Like education, that's one of the reasons why, like for me, I'm super passionate about doing these podcasts, because I mean, if this information can get to 1 or 2 or 3 engineers that may experiment with your product or another manufacturer's product, it levels up the industry, right? And the more people that know about non-traditional methods, the better it is for everybody. Our competitors, for you, your competitors. It just makes the pie that much bigger.
Yeah, that's why we make such a big investment in engineer outreach. It's just for that reason. There's so. I mean, Andy can tell you he does a lot of these lunch learn presentations. We give out PDH credits, but a lot of times they'll be talking, and then people will raise their hand. I have this project right now. And you end up talking to them afterwards, and it turns into a real project.
Yeah.
Yeah, that happened with ECS in Charlotte, and then we did that. We brought the Dry Pro guys over there. We did that one, just one, and we've done work with ECS in Florida and Tennessee and other states, and so it wasn't like a cold call trying to do our first one for the Charlotte branch, and they had some stuff right away. And turned into some nice projects.
Yeah, one of the things just on the Dry Pro end, like Andrew Jones does a lot of leak seal and a lot of DOT work or work for the city. On a typical like manhole repair or small little culvert or what would the cost of replacing something like that be versus us doing a leak seal project?
Yeah, it's all over the board, because you've got brick manholes, you've got precast manholes, right? Precast a little easier because there's less area for the water infiltration. Andy, you want to talk about the
Well, I could talk about a water district down in Florida, and I know the numbers because these are current numbers, because I was just talking to an engineer down there who is good buddies with the guy that runs. He's the chief engineer for this water district. So this is going to be a worst case scenario, because the system they have is deep. Their sewer system runs between 20 to 30 feet deep. They do that so they can space the lift stations further apart. But when there's work that has to be done, they're way down in the water table there. So they got 3-4 foot water table there. If there's a manhole that had to be excavated and replaced in the grass, like out past the sidewalk, just over in the grass, $750,000. If the manhole is in the road, it's $1 million, and now you've got the road shut down, and with the sandy soil, the high water table, you've got all that dewatering. You never know what you'll run into with dewatering, and then they have to bench back these excavations because of all the sand and the OSHA. Florida's got really strict trench safety rules that supersede even OSHA. Yeah, $1 million to do that, and
to replace it.
We actually went and grouted around one of these that was 25 feet deep, stabilized the soil all around the manhole, which is the result of the infiltration of the water. Causes the soil to go, and then causes the road to start going down.
Sucks the soil into the pipe and then takes it out.
It's all connected. And so I can't help it. Every time I go down the street and I see a curb inlet or a manhole, you'll see a patch, or you'll see cracked asphalt, or something settled, or the curb's going down. I mean, it's so much of that out there.
Everyone in the country. I mean, we were driving down the road the other day, and it was one after another after. There's a manhole and there's a pothole. There's a manhole, there's a pothole. There's a drop inlet and there's a pothole.
And a patch and another patch and another patch.
And another patch, yeah.
And because they're just patching the road, they're not fixing the problem. And fixing the problem is actually pretty inexpensive.
It's really so. Like in that scenario, what would be the cost to leak seal or fix or?
So we did. The contractor on that one used almost a full tote of material, because we were going 25 feet deep. We did a circular array, a double array around the manhole because we were tightening up all the soil. The leaks were already sealed because they'd put a liner in there. They were really trying to just get the road back up to snuff around that manhole. These products that single components are hydrophobic, so they are heavier than water. They'll displace water out of the soil even as they react with them. And so we do that grid around there, and you're pumping about a gallon per vertical foot as we pull our pipes up. And then you go to the next one, and the next one, going around that manhole and then around it another time. They charged them about $25,000 to do it, and they did it in about 6 hours to do that job.
So
Versus-
with $25,000 versus $1 million.
versus $1 million, because this one
That's pretty cost effective.
This one was in the road. Also, minimal lane closure, minimal disruption to a busy area. It's an area outside of Disney World is really, really busy. So stopping lanes and shutting down roads is a big, very much of a headache.
Option.
Very much of a headache down in Orlando. So, we say, it's one of our calling cards. We always say, our technology saves people time, cost, and disruption over traditional methods. Fraction of the time, fraction of the cost, fraction of the disruption. What's not to like about that? And they get to the root cause of the problem, and then you don't have to go back ever again to fix it.
Yeah.
So.
I like that. So how did y'all's chemical and your product lines evolve? Like, did it come from new challenges and new experiences and new contractors brought you a problem, and like how did the evolution of your product line begin? And I want to talk a little bit specifically about the two product lines that you have three product lines, I think, right? But let's talk a little bit about that.
Sure. So the three product lines you're talking about are the geotechnical, which is the slab lifting,
Right.
the soil stabilization, the deep lock method. Leak seal is the other one, is the second one, and then seawall repair is the third one.
Right.
And seawall repair is really a combination of the other two. It's really a geotechnical application because you're filling voids, you're stabilizing the soil. But the problem with seawalls is water exfiltrating through the wall at the joints, carrying soil with it, right? So you're also sealing leaks. The first thing you're doing actually is sealing the leaks, and then doing the other types. So as we started the company, we had both geotech and leak seal to begin with, but we were much heavier on the geotechnical. There was a real boom in Florida back around 2013, 2014, where they had changed some insurance laws. And because of that, everybody was filing a sinkhole claim on their houses, and they were just stacked up, just
Wow.
millions and millions of dollars worth of work. It was the Wild West at that time. So we were very heavy into that. In 2017 or 2016, actually, I had one of our competitors from Belgium
Okay.
approached me. They were making product in Belgium, shipping it to the U.S., and they were looking for somebody to buy in the U.S. that could make their product here and manage their sales team. I had no interest in selling, but I knew I wanted to sell the business at some point. So I talked to them, and the more we talked, the more I realized this is a pretty good partnership here, because they were very heavy, and in fact, one of the top companies in the world on the leak seal side of the business, and we were very heavy in geotech. Their business model was to sell through distribution. Ours was to sell direct. So it was a really good mix of products and access to markets. So we ended up merging those two businesses.
Nice.
Andy told you earlier, the business I first started was Alchemy Polymers. Alchemy Polymers is now one of our brands. So all of our two-component materials, they're all AP Lift 430, AP Lift 440. AP is for Alchemy Polymers.
Got it.
So when we merged, their company, it was called Resiplast, but it owned a brand called Spetech. So we merged those two, the two businesses together, my operation, their U.S. operation, and formed Alchemy Spetech in 2017. And then we realized Alchemy is a brand, Spetech is a brand. That's not a company. We just jammed them together. We came out with Seawall Repair Network. That was a third brand. And so we decided to come up with an umbrella company that we could put all those brands up underneath.
Right.
So that's when we rebranded 2 years ago, 3 years ago, something like that, to Alchatek.
Yeah, it was May of over
So it's
two
Alchemy
years
and
ago.
Speed Tech.
Pretty much, yeah. Yep.
Like how creative were those conversations? Was it just like pretty quick, or were y'all like going back and forth?
No, it was a long drawn out process.
Okay.
And it's funny, we'd hired a guy to do our logo for us, and he was a real good branding guy, and we had a meeting, and I had written out names. I had probably 30 names written out.
Yeah.
Of course, you got to check the URL, make sure that you can get the
Yeah.
website, and make sure
Yeah.
there's nothing's trademarked. So we hired this guy, and he comes. He says, "I think I got it." He says, "I woke up at 3 a.m, and I think I got it. It was Alchatek." And I pulled my piece of paper out that had the 30 names on it, and I had literally highlighted Alchatek. That was one of the names, and I had highlighted only that one name.
That's
I was
awesome.
like, "That's it. It must be the right one."
Must be the right one. That's cool.
Yeah. So you're asking about how the product lines evolved. So certainly, merging with this Belgian-based company that had just absolute world-class leak seal products. We had really good leak seal products as well, but they had a broader range. And then on the two component side, we started out with our AP Lift 475, and that's because that's what we needed to use in China because it's a very heavy duty. It's a 4.75 pound density foam. It's very heavy duty. So that's what we started with. And then we saw the potential in the residential market. That doesn't need to be as heavy. So we came out with a 3 pound foam. And then since then, we've just evolved it. There's applications for a 2 pound foam, a 3 pound foam, a 4 pound foam, 4.75, and a 6 pound real strong structural foam.
What would you use a 6 pound foam for?
Pennsylvania DOT, because they think they need a 6 pound foam, while California DOT thinks a 3 pound foam is fine, and California DOT is right, and Pennsylvania DOT is right. It's just
at the end of the day, there's not a lot of difference. So if we mix the foams up here, a 2 pound is going to expand a lot. It's going to be really lightweight and not super strong. A 6 pound foam is going to expand just a little bit, but it's going to be really strong. That's what we call free foam. So mixing it up here in a cup, that's what you're going to get. When you pump that stuff into the ground, it doesn't fully expand. So your 3 pound foam is probably going to turn into a 6 pound foam anyway.
Yeah, because you're putting it into a confined space. And
yeah, not necessarily just under a slab, because it doesn't take much pressure to lift a slab. But when you're doing the deep lock method and pumping through pipes into the ground, certainly there's not much difference between a 3 pound foam or even a 2 pound. We have a 2 pound foam that we called, it's our deep lift process. So it's actually designed for lifting structures. But it's a 2 pound foam.
interesting.
What we wanted was something that was extremely aggressive, extremely fast setting, and expands a lot to try and get lift. But once you get that lift, then your soil's strong enough to hold the structure.
if you remember why you talk about the market kind of creating the demand for our product. When we started, we were making the 475, but in the residential market, we discovered there was people using 2 pound and people using 4 pound. And this one guy, I'll never forget, that one guy out in Kansas City, he kept calling and saying, "I keep having callbacks on my 2 pound, and we're like, well, buy our 475. And then he's like, it's too expensive. And I'm like, well, what's the callbacks costing? And we never could get that guy to buy a set of material. And then we realized maybe the sweet spot is a 3 pound foam where you get the combination of good void fill, because half the work we do is filling voids, doing preventative before that concrete sinks or cracks because it's got a void under it. So we said this is best of both worlds. A 3 pound, it's going to lift like crazy. It's strong enough to support really any kind of slab, and it's got good expansion for the void fill. And so we did the 430, and that's what we first started doing work with JES and JES and Mount Valley. I got introduced to Greg Renfrey through Alan over there. Your mechanical engineering wizard over there over in Columbia. He introduced me to Greg. Greg's like, "You got foam?" So I was like, "I got foam, yeah."
That was back before Groundworks was Groundworks.
There was no Groundworks. There was no IMG. There was none of any of that. So I was like, yeah. And so that's Groundworks started using, JS, and then Mount Valley, and then Indiana Foundation. They started using our 3 pound, and
you talk about product
how it got going.
Advancement. So our 3 pound foam, we really like that product. We sold a ton of it. It does a really good job. we had some customers that felt like it wasn't fast enough.
Mm.
And there's always
what's the set time on it? Gel time, set time.
Well, it's the standard version is 25 seconds, something like that. But we've just come out with a fast. Well, we've had a fast version, but we reformulated it, and it is fantastic. It's very fast. It gets hard really quick, and it's extremely hydrophobic. So it gives you everything that you need. I think right now it's the best product on the market.
Nice.
That's the 430 fast.
And you use that for lifting, filling voids, all the
Most
above.
of the residential stuff.
Yeah.
Yep.
Yeah, I was blown away by, because we've always been known, we've never been the lowest cost guys on the market. We've always had good quality, real good consistency. But that one, I'm a skeptical about like things. I gotta see it. I gotta prove it. And when I grabbed that 430 fast and I could not crush it, and it's only five minutes in, and then I couldn't even tear it apart. I was like, this is some new level of product. So I got hats off to our chemists working on that and working on it to get it right.
I'm interested in, there's a lot of different, we're at the DFI and there are tons of different manufacturers manufacturing different things like acrylamides, acrylites, if that's
acrylates, yeah.
And different types of single component and dual component. I mean, I think I probably saw 40 or 50 different types of products. There was one that was some kind of gel foam that looked like Laffy Taffy, and it was like a leak seal product.
Yeah, we have that product.
So is there anything different in your manufacturing process without giving up the juice or the goods or the gold? Is there anything different about what you guys do? Is it in the raw materials, the sourcing, or is it similar?
It's a combination of everything. It really comes down to, what do you need the product to do? Right? You always have to start there, and then you design the resin. Do you need something that's low viscosity? Do you need something that's fast setting? Do you need something that's rigid? Do you need something that's flexible? Do you need something that's hydrophilic? Do you need something that's hydrophobic and is going to repel water? So you start with all of those things, and then you just start building that base chemistry up. And so there's a lot of companies that do things like that, right? The polyurethane technology has been around for a long time.
Yeah.
There's a lot of companies that can make polyurethane foam. The real key and our secret sauce is knowing what to do with that product, knowing exactly when to use it and when not to use it, and when to use this one instead of that one. A lot of times we could have 5 products, and all 5 products will do the job. Like, I could do the job with any of these 5, but I'm going to pick one of them for a specific reason. Either, you got a tight crack, you need something really low viscosity in there. You've got some movement, so you need something flexible. Maybe in an area that dries out, so you want something that's hydrophobic. It may be in an area that's full of water. You might need something that's hydrophobic. So it's really understanding all of those things, how the equipment works, how the material works with the equipment, and then that installation technique. And we like to work with our customers, as you've seen, like a partner, side by side. We want to come out and train your people and teach them everything we know. We've got some of the best training guys in the industry. They love what they're doing, and people get on site with them, and they end up loving what they're doing too.
Absolutely. I would say also just staying kind of laser focused. I remember early on, there was a lot of movement in the spray foam industry. People were acquiring each other, and Steve was like, man, maybe we should start a spray foam business where we'll make spray foam and then we'll sell it, just do something real quick. So we worked with chemists to get the formulas. We were thinking we'll be using a lot of the same raw materials. This is going to be, no-brainer because we're already using all these things. Wasn't any of the raw materials were the same, except the A side. So like 11 different raw materials.
One of the main raw materials in open cell foam is sugar.
Yeah.
Really?
Liquid sugar.
Yeah.
Really?
Yeah, that's a primary ingredient.
Wow.
And it's funny because we made a half-pound open cell foam, and you go to burn it, and it would smell sweet. Like you could smell that sugar.
Creme brulee.
Yeah, exactly.
Interesting.
But we put that to bed when we realized it's not a good decision for us, and it helped us just stay focused. Let's do what we do and try to do it really, really well, because there's such a huge pie for it.
Yeah, it is. So on that, a lot of people don't know the difference between like open and closed cell foam. open cell will allow moisture to get into it, right? It's not going to, is it hydrophobic or no?
It's not really it's hydrophobic because it doesn't chemically absorb the water, but it's open cell. That means that the water can travel through the foam.
Right. So I have a lot of experience dealing with repairing structures from that. Like early on in insulation in Texas, there was a big wave of people that just said, you know what, we're going to come in with open cell, where the poly insulators and what they do. I mean, you've been to Texas; it's humid like it is here, right? It's just humidity like crazy. And what they would do is they'd go in and they'd spray crawl spaces to insulate them. They'd go in and 6-8 inches of foam, like on joists and girders and all
Creating
that.
a nice mold problem.
Mold problem, rot. I mean, we would go underneath these structures, and you'd grab the foam and you'd take the joists with it. It was just you had dry rot, moisture rot, because all the moisture from the ground would sit in the open cell foam, wick into the wood, and just completely fall apart. And then, eventually, after tons and tons and tons of claims, the industry started adopting like a closed cell foam and understanding the difference between where you can use an open cell and closed foam.
Right.
But with those two products, why is it not a good idea for a spray foam company to just go, oh man, we'll go ahead and shoot some foam in your concrete with our rig after we're done with insulating your house?
Well, several reasons. One of the big reasons. Well, first of all, the 2-pound foam isn't structural. I would not put that up under a concrete slab unless I was going deep into the soil.
Got it.
But that's one reason, is that spray foam is basically, if you have open cell is 1/2-pound foam, expands like crazy. Closed cell is around 2. And the ideal insulation is between like 1.8 and 2.1 or 2.2 pounds, something like that. Gives you the ideal insulation value. The 1/2-pound foam is much less insulative, but it expands so much that it's cheaper. So you can get that R value with less.
Oh, got it.
But the other thing is that the spray foam is so fast. And we've seen products in our industry that people are using right now that I think are too fast. And what happens when you lift a slab with a foam that's too fast, it comes up nice and quickly, which is what the installers like. The problem is that you're building a column. Yeah. Right? And you end up point loading the concrete, and it
like a bunch of cow patties.
Exactly. Yeah. And then so what happens is you point load it, and when you put weight on it, the concrete can crack.
Yeah.
Or you're putting all of that weight on a small area, the little cow patties you're talking about, and it ends up crushing.
Yeah.
So you need something that's fast, but not too fast, so that it'll flow.
Something that's going to fill the annular space and get everything.
Exactly.
Because the minute you lift one area, you're going to you lift a rectangle that's down. Even if you get this foam underneath here, you're still going to have a gap between the soil and the underside of the concrete.
Yeah. That's how all the helical pier companies got into foam, because they would lift and then they would create a void. And the guys that got in early were the ones that were saying, well, we need to fill this void, so let's get this spray foam equipment, get some geotechnical foam and fill the voids. And then they realized we can actually lift structures with this. We can lift driveways. And the business just kind of grew like that. But that's what we saw in the early days. It was all the foundation repair contractors.
So I've been in foundation repair since high school. And so I saw a lot of that early on when the foam industry started. You'd pier and you'd lift, and not a good idea to fill voids in expansive clay when you pier something from the outside.
Right.
What do you think can happen when you fill a void during a drought with expansive clay?
You're probably going to buckle your floors. You're going to push up.
The soil's going to swell, and it's going to lift that mass and pick the interior up.
You're going to have a big problem.
Yeah.
I don't envy. We have clay here. It's hard as a brick, red clay, but it doesn't do.
It's interesting. I was reading an engineering report the other day, and maybe but there's a mineral specifically, like out here in Atlanta in the soil. There's a mineral that causes the clay to shrink, and I can't remember.
Maybe it's lime. I know they
And
do lime.
maybe-
I know they do lime injection on expansive clay to try and prevent it from doing that.
But it's specific to the settlement. It's like it was talking about this clay settles on the order of X because of this mineral. I'm gonna have to go back and read that engineer report.
Yeah, that's interesting. I'd like to know what that is.
Yeah,
It's like kaolin or something like that, because since it's kind of local, you say it's from this area.
It is like up in Marietta area. So
Most of our kaolin mines and stuff are in
South
central Georgia and South Georgia.
Yeah.
Because you can see them when you fly to Florida. You can look out the window and you can pick them out.
So what kind of solution, or not what kind of solutions, what kind of problems can we solve with geotechnical polymers, leak seal? Like, let's just run through them. For those that don't know, let's give it up. Let's talk about what we can solve and what we can fix and what the products look like.
Yeah. So from a broad standpoint, any type of geotechnical problem really can be. So we call these materials chemical grout. Right. So it's a chemical and it's a grout. Well, what does a grout mean? Right. Most people think of tile grout. That's filling a gap between tiles. Right. But there's cement grouts. There's the acrylic grouts. There's the acrylamide grouts. There's the polyurethane grouts. There's tons of different products out there. A grout is simply something that fills a space. So it's a very generic definition. But when you think about that, what causes problems? Erosion.
Yeah.
Settlement due to trash pits or biological decay, things like that, and so
decomposition of root structure,
exactly,
or compaction in the first place.
So you're creating voids, and the chemical grout, the products that we manufacture, they're designed to go in, seek out those areas. They always follow the path of least resistance.
Yep.
They're going to go along in those gaps and fill them up and give you enough strength for whatever structure's sitting on top of it. So that's kind of the broad overview. Andy, you want to talk about some of the specific applications?
Golly, I do one presentation for engineers. It's called my market segment presentation, because if you go on an engineer website, they'll usually put what market segments that they work in, and you might see, okay, it's energy, government, entertainment, retail, multifamily, housing. And so I was like, we do stuff in all those segments. So I want to create my own presentation that looks like an engineer website where I'll have a drop down with all the segments. And I ran out of space on the page because there's so many market segments. So I went in alphabetical order. Agricultural stuff. So we've lifted slabs in agricultural facilities where they've had settlement. A lot of, big agriculture. Huge tanks, silo slabs that need to be re-leveled because they're on load cells. So we've stopped water from getting into underground bins where they unload grain into grain hoppers at these different grain co-ops. Then you get into the ADA compliance. There's all your slab lifting, or maybe it's doing soil stabilization for putting an elevator pit in because a building doesn't have an elevator, so it's not ADA compliant. So, and you can just go down through the alphabet. Army Corps projects, water control structures, filling voids, stopping water from getting through the soil around water control structures. And just commercial buildings. Parking garages have leaks. Yeah, I have a whole section on dams, injecting a big arch dam with leaks, or a soil dam. A lot of people don't know how many dams there actually are there. Georgia has over 5,000 dams.
That's a lot of dams.
Regulated by the state dam safety officials, and 17 are concrete. The rest are either stone, and the majority are soil dams. And soil dams are prone for all kinds of leaks, especially where you got water going around the overflow control structure, pipes and things like that. Water going around the pipe instead of through it. So, so we seal those up with single component resins. Just go down through the alphabet, the education,
power plants. Box culverts,
solar fields,
any kind of drainage on a roadway, right?
Yeah.
Everything that's transporting water like that is subject to leak, and then the leaks bring in the soil, erodes the soil, and then you've got weak soil around those structures, and they can shift.
Yeah, bridge approach slabs. Some of the pioneers from our industry, the guys from Urotech, for example, you guys have bought a couple You got your Eagle lift there. So
Yeah, no, I'm going to give a quick shout out to Cliff.
we'll give a shout out to
How's it
Cliff.
going?
I'm rocking your Eagle Lift brand today, bro.
That's right, Cliff. So, they're experts at raising approach slabs and fixing that big dip on the approach, coming up to a bridge or on the exit slab, coming off the bridge. Everybody's experienced that, and raising those things up is just fascinating. And it's just on and on. Sealing leaks in the MARTA tunnels. We have a big leak seal project going on right now in Los Angeles on the expansion of their subway system as they're tunneling through. They got water coming in through really tight fissures in the ground, and we're using acrylic resins to seal those up, stop that water from getting in. It's just unlimited, the amount. I mean, if you just say a house, interior slabs, driveway, pool deck, sidewalk, front porch, back patio, carport, garage slab, everywhere around us, under the foundation.
Maybe you could say like where water finds a way, we find a way to stop it.
Yeah.
That's right. We used to have some advertising we did, and we said water is relentless. And we had a big picture of a giant mako shark on our booth. That was really cool.
That was cool.
That was the coolest booth we ever had. It was Alchemy Polymers, and we had a giant mako shark. We paid for that picture so we could own the rights to it. Imagine a 10 by 10 booth with a giant backdrop of a huge mako shark, and that's
just swimming through the water.
And it just says water is relentless. I was at the it was actually the same show. It's the Society of American Military Engineers. So we went to that show, and there was all kind of people that want to do business with the government. And we had that big shark backdrop. And here comes the 4-star general for the Army Corps is marching up with his aides all carrying their briefcases in for him. And he stops and turns and looks at me and looks at our booth, and he walked over and he's like, "What does Alchemy Polymers do?" And I said, "We kick water's ass, sir." And he was like, shook my hands. He's like, "Keep up the good work," and walked off. And I was like,
awesome.
that's the 4-star general. That's like, that's so cool.
But yeah, it's any below grade structure, utility vaults, parking garages. I mean, they're all going to have leaks. Water wants to get through, and we can do everything we can to try and stop it. But eventually, it's going to come through.
Yeah,
it's got nothing but time.
Absolutely.
That's why we say it's relentless. So, but it's our friend, though. We get a lot of business because of water.
It is, and in every part of every city across the country has different issues, different soils, different structures, different applications. Every time that I see another problem, like I'll call you or call other people and be like, "Hey, have you ever seen this before?" "No, but we can figure it out, and we can do this, and we'll find a way." Right.
Yep.
What do you? Have you ever seen a project that you just said we can't do that?
Yeah,
well, I got an email today actually from somebody that was asking about sealing around some steam pipes, and he said the temperature around the outside of the pipe can get to 700, 800 degrees, and I was like, any polyurethane is going to fail in that environment, so no, don't do that.
Not going to work.
Yeah,
no, that's good.
And sometimes chemical, like if you're working in a plant that's using chemicals and there's chemicals in the soil. If it's a very high pH or a very low pH, the foam won't react well. So some of those situations.
Okay.
But as far as lifting, we lifted a 17-ton grain silo that was sitting on a 3-foot thick slab of concrete.
Wow.
It's just amazing how much. It really doesn't take much pressure to lift a structure. You just got to get it evenly spaced underneath it.
You got to know what you're doing, how to space it, how to dial it in.
Yep.
Yeah, or sometimes it's a soil type. We have some contractors get a little overzealous. They're like, "I want to, I saw that in your presentation, an excavation assist where you glued all the soil together and you excavated next to it, and there's a wall of permeated soil right there. And we got one we want to do that on, but they've got the wrong kind of soil. We got clay and silt and mush, and I'm like, it's not going to work, Is there a soil report? Yeah, here it is, and it's like, we can't permeate any of that. How are we going to glue all that together? For safety's sake, we have to step back.
Yeah, part of being with y'all, like being a good partner, knowing when to tell your contractor, no, you can't do that.
Absolutely.
Don't do that. That's not going to work.
Yep.
I definitely appreciate that.
Now we've also we've also seen some where we know it'll work, but it's going to cost a fortune, and I don't think this is going to fly compared to maybe just running some sheet pile through there.
Right.
But okay, we'll do the exercise and we'll run it out, and then you generally kind of know where that price point is. They're never going to go for this. However, over the last few years, we've been landing some of those jobs that maybe we wouldn't land before, because these other methods would require dewatering. And
Right.
our products can be used without having to do dewatering because they're heavier than water, they're hydrophobic, so they push water out of the way. And then when they react and expand, they're closed cell and they push water further away. And the other method might require dewatering.
And what's the problem with dewatering?
And the dewatering problem is, one, the engineers won't engineer it. They leave that up to the contractors, so they'll use it. So the engineers don't want to have any part of the dewatering plan because they'll over-engineer it. It'll be so expensive to do dewatering. But also,
It's expensive anyway.
people are testing. Used to look at the soil report 10 years ago, and there might be no pages on what's in the groundwater. Now there might be 40 pages of groundwater analysis, especially if it's an industrial site. And they're like, all this water that you're pumping out has got to be treated.
Mm-hmm.
And you're going to be pumping millions of gallons over time on this project. Now you're treating all that. That polyurethane is starting to look pretty good
Yeah.
as an option now all of a sudden. So it's coming around
No,
for
I
those
like
big
that.
ones. Mm-hmm.
What's something people don't know about you? What's something cool about you, or something people don't know about you?
Well, I think something cool about me is some of the things I've done in my life. I've had an opportunity in my life to travel pretty extensively in a lot of places around the world and see a lot of things that really make you appreciate, one, the world, but even more appreciate home.
Mm-hmm.
So I probably spent more than a year of my life in China, over 40 to 50 trips
Wow.
going to China. I was telling Steve the other day, I was like, Steve, I've been in Japan like 80 or 90 times. I've only been out of the airport once or twice because I missed a flight. And even then, they grab you and stick you in
You
a...
should book him like an Airbnb
Yeah.
for like a week. Just be like, cool, go to Japan, hang out.
It would be
I've also been
cool.
to the airport in Japan, but never outside.
Yeah. So spent a lot of time going to Turkey. When we worked with the companies in Germany, when we were building the concrete pipe plants, we would go to Germany and Italy and France quite a bit.
That's freaking awesome.
So yeah, I've gotten an opportunity to see a lot of really, I was in an earthquake in Turkey, not a major one, but
Yeah.
like 2 weeks after I left, they had the huge big one that killed like 40,000 people. And that was like a precursor to the big one because I had just come back, and 2 weeks later they had that huge one. And so just seeing a lot of crazy stuff, other wild cultures. Been in some pretty poor, remote, not so much remote, but just poor places in China. And it makes you, I remember going in this one, we went to this village where one of the guy that owned the factory, we were a foundry, he's like, my school teacher, the principal of our school who lives here in the village, let's go see her. And we went there, and she lived in a brick building, basically with dirt floors. And she's handing us like tangerines and nuts, and she's trying to give us things, being so generous and gracious and so excited to have a guest coming in, some American guy coming in here and wanting to just give me everything. And it was very humbling, to see things like that. And, makes you really love people and you care about people, and you're like, why can't we all get along, right?
Yeah. And so for me, one of the things, like I had a mentor when I was younger and was like, what do you recommend? Like if you were to give me one thing of advice, and I'll never forget, he said, travel. It's going to change your perspective.
Yeah.
People that have like an evil perspective, or they think, this one group is this way or this one group is that way, oftentimes have a limited perspective, or they haven't seen other cultures or been out and around. And Man, I've done the same thing. I've had the opportunity to travel and experience a lot of different things just through work. And you know, people are people. We're all just living, and
Trying to make it.
Everybody has a different experience. Different cultures have different things. But I mean, at the end of the day, we're all human, and that's pretty cool. So, what about you, Steve? What's something? I mean, if there's anything cool about you, like
I wouldn't be his friend if he wasn't cool.
like
Just do a lot of work. So I don't do it so much anymore, but I used to free dive a lot.
really.
Mm-hmm.
So
Yeah.
that's like what's free diving?
So that's it's like snorkeling, but going deep. And you're using big giant fins, and you're holding your breath, so it's not scuba. I'm
okay.
certified scuba also, but I like free diving better.
Why? Why'd you like it?
Oh, okay. So I was watching this fishing show, and they were free diving and spear fishing, and I'd watched the show for a long time. And the main guy on the show, he shot a dolphin or mahi mahi, not a flipper dolphin, but mahi mahi, and he was fighting it, and the thing was just going around and around, and he was trying to pull it in, and he finally got it close to him, and he pulled it in, and he reached up into its gills and grabbed both gills and ripped them out, and blood just went out into the water like that. And I said, "That is cool. I want to do that." So I went out and signed up for free diving classes.
Wow.
And the people that taught the class, they were world record holders. One guy had the world record for the longest breath hold, and it was like 11 and a half minutes.
Wow.
Now they're up to like, I don't know, 18 or 20. It's
crazy.
It's crazy, yeah. But Andy and I used to train. So when you free dive, you have to have a partner that's trained. So Andy's bonus one year, I said, "Hey, you're going to take this class with me," because I needed a buddy that was trained and could keep me from dying.
Yeah.
So
that's good.
We went and took this class, and actually, it was at that class we were offshore. They dropped us off South Beach, or they took us out in South Beach. We went out in the Gulf Stream, got in the water, 600-700 feet of water, couldn't see anything. By the time we got out at the end of the day, we were at West Palm. We had floated, it was like 17 miles, something like that.
70 or
Man.
So I mean, it was all day out there from Miami to West Palm. It's a little bit of a haul, right?
Crazy.
So on that trip, they have this set up. It's hard to explain, but it's carbon fiber rods that go out. They're like 40 feet long. And then at the end there's a rope that goes between them, and then the ropes go down, and there's a target, and they can raise them up and down. There's like a 10-pound weight under the targets, so they could lower them down to different depths, raise them up to different depths, and then you would do your breathe up and then dive down, touch and come back. So we were doing that, and we did it all. It was all day for 2 days, and it was getting towards the end of the second day, and all we had seen is blue water, no fish, nothing. And it was my turn to dive, and I was doing my breathe up, and I saw this little fish down there, or this little tail was wagging like this. And I was like, "Oh, that's pretty cool. Maybe he'll be down there when I get down there." And when you're free diving, you get hypoxic, right? So that means your blood oxygen gets low, and you don't think super clear. And just as I was about to dive, I looked and I was like, "It's got a pointed nose. That's a dolphin." And then right when I started kicking down, I was like, "That's a shark."
Holy cow.
And I went, and it was at 50 feet. So I'm holding my breath, kicked down to 50 feet, grabbed the rope, and you're kicking down, and then I flipped over. And when I flipped over, he rolled over and looked at me, and his eyeball was like this big. And it was just me and him, 50 feet. I'm holding my breath, and I could hear my heartbeat slowing down. When you free dive, when you get to a certain depth, it's part of it's called a mammalian mammalian response, and your heart rate slows down. And I could hear my heartbeat slowing down as the shark was circling me. And so I just kind of hung on there for a minute, and I was thinking, well, I could shove this rope in his mouth. That's about all that I have to defend myself. But he didn't. He wasn't aggressive. He was just checking us out. So he circled me. And finally, I needed to breathe, so I just reached up real slowly and pulled on the rope. And right when I did that, he came came in, got about probably 10 feet from me, and then took off.
Wow.
When
I'm up top watching.
When I broke the surface, yeah, Andy was up top. As soon as I broke the surface, Andy goes, "What kind of shark was that? Was that a great white?" And I thought,
that's awesome.
I have no idea. I had no idea I never thought what kind of shark it is because I was, like I said, I was hypoxic. I wasn't thinking.
It was a mako shark.
It was a mako.
Yeah, it was a mako. I'm watching from up top because I had just gone down to the target and come back up. My job is to watch my buddy go down, and if he gets in distress, and I'm watching this shark come in and going around Steve, and I'm thinking, I don't know how to run a company, you know? This thing, we're going to go out of business in no time.
Like, bro, don't I?
So
that's awesome.
It's good to see him come back up in one piece.
Man, that's nuts about the shark. So
yeah, it was interesting.
Could have been gone.
That's why we ended up putting a giant mako on our
that's awesome.
our booth. Yeah. Well, so we went the deep. We used to dive in practice in a quarry up in North Georgia, and that's my record depth. I went to 107 feet holding my breath. That's a lot of fun.
That's awesome,
especially in a quarry where you can't see anything.
You can't see anything.
The water's freezing cold.
That's really cool. I'm glad I asked. That's neat. Look, I really appreciate you guys taking the time and spending the time tonight. It's always fun hanging out with you guys and all that. You guys have any questions for me? I mean, I'm always asking questions.
We'll have some, but we only have 2 minutes. So.
You got one.
Okay, one question. What's the big? So Groundworks is trying to grow your commercial division. You're one of the leaders there. What are the biggest challenges that you guys are having right now?
I think it's just that, when things are going fast, and you're scaling fast, I think that for me, I think the thing that I always have to think about is focus on the difficulty of keeping things simple. That there's basic foundation building blocks to building a business, and there's basic foundation elements that need to be laid that translate to everything. And just when things are at scale, it's very easy to try to want to complicate things or whatnot. But at the end of the day, it's a daily reminder of focus on the difficulty of making things simple, and not getting some complex whatever.
And why is that important?
Why is it important? Because if you try to complicate things, then you can't move at speed. You can't scale fast. You end up not being able to deliver a message effectively. It affects your scalability. I mean, if you make everything super complicated, you can't scale it.
Right. Makes sense.
Good stuff. Well, thank you.
Yeah, thank you.
Thanks for hosting us, Justin.
Thanks for having us.
Yeah, it was
awesome. Thanks, Groundworks. Y'all have we've been working together for 8 or 9 years. Not as Groundworks the whole time, but y'all been real good to us, and we appreciate that a lot. So, thank you.
No, we appreciate the partnership too. So
great.
Cool.
All right.
Let's do it.
All right.